Continuing with ecology pertaining to pyramid of numbers. Now, whatever you're seeing here is actually starting off the food chain with a single producer. So it has a very narrow base that you only have a single tree, and you can see that there's much more primary consumer, and you start to get a little bit lesser secondary consumer, and lastly your tertiary consumer, or you can just call this as your apex predator for this food chain. However, I encourage you to think of that of pyramid of biomass. Now, prior to talking about pyramid of biomass, is to note that pyramids of numbers often have a few different shapes. So the first one that you're seeing here is whereby I call this as the Christmas tree shape, right? Where you can see that it has a very narrow base, and this is courtesy of actually having a very small number of producer. Now the next variation over here, we'll call this as an hourglass shape, whereby you have a large number of producer, but at the top itself there was a parasitic situation over here. So there is a large number of parasites that reside on the body of one of the consumer itself. So combining both of these, we could have a very narrow base, indicating that we have a very low number of producer. And also at the top of this food chain, there is a parasitic problem as well. Now these are the variations with regards to pyramids of numbers. Now, however, when it comes to pyramid of biomass, the shape itself is always standardized. It could only act on that of like a pyramid by itself. Now, for the case of the tree here, why does it still have a very large biomass? Is because the tree contains a large amount of cellulose. And cellulose itself contributes to a very massive dry mass of the tree itself. So irregardless of a single tree is actually having a lot of cellulose, the dry mass is extremely high. It will still result in a very large base at the bottom of the pyramid of biomass. And you can see that as we are scaling upwards, especially for the case of caterpillars that's 10,000, it's due to note that the per dry mass of the caterpillar is actually extremely low. So even with a large number of caterpillars, the combined dry mass of the caterpillars at that trophic level is actually much lesser as compared to that of a single tree. So although as we go upwards, the dry mass for each of the trophic level is seeing an increase, the per dry mass of the organism is still going to be higher, but we have lesser of those organisms. So taking a high dry mass but multiplying by a small number of the organism at the trophic level will also result in a much narrower bar as compared to the previous trophic level. So in this case here, which of the statement is correct? A is going to be incorrect here, although we have a large number of caterpillars, but having a very low dry mass per caterpillar leads to a very small total biomass. Now for the case of B here, the large bird has more total biomass than the small birds. The word total biomass itself is once again trying to have you see that the biomass is actually going to be a multiplication of the number of organisms and each of the dry mass. So having a very high dry mass but having very little of the organism in that trophic level will still result in a very low total biomass. So similarly for part C here, the small birds having more total biomass than the caterpillars is not going to work out with the same argument in option B. So leaving D to be the correct answer here, once again telling you that a single tree still have a massive amount of cellulose that will still contribute to a very high dry mass.